Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from the set Calculating Frequency and Wavelength from Displacement Graphs. So we're keeping track of the vertical position as a function of time. They describe it as a vibrating string. It's hard to imagine this system, jiggling a slinky or something like that, because it starts 3 meters away from the equilibrium position. So this is 0 seconds. 3 meters above the equilibrium position right here. And then 1 second later, bam, it's 3 meters below the equilibrium position. All right, so that means it takes 2 seconds to get through 1 cycle. That is the period. All right, but they want to know what happens to the period if the frequency doubles, okay? So not a cycle every 2 seconds, but a cycle every 1 second. And I was sort of struggling to figure out a mechanical system that had a period of 2 seconds. So I thought, well, how about a pendulum? All right, so here's the pendulum equation. Period equals 2 pi square root of length divided by the acceleration due to gravity. There's the pendulum equation. And so all you do is you put in 2 for the period. 2 divided by 2 is 1. So you would do pi squared multiplied by g, 9.8, equals the pendulum that has a period of 2 seconds. Well, the crazy thing is, it's about a meter. A pendulum with a length of, I calculated, 0.99 meters has a period of 2 seconds. So I actually made a little pendulum that is basically 1 meter long. And let's see if my prediction works. So tick, tock. Is that 2 seconds? Start, stop. Well, according to my calculations, this system has a period of 2 seconds. Tick, tock. I don't know. You can put a stopwatch on it if you want, or you could make your own pendulum that's a meter long. Remember, the definition of the length of the pendulum is from the pivot or the fulcrum to the center of gravity. So it's actually the middle of my little wooden blocks. How could you modify the pendulum to double the frequency? Should you make it half as big? Well, that's when things get crazy, because this is not a simple function. The period of the pendulum is dependent on the square root of the length, so I'm going to leave that as a little puzzle for you to figure out. How would you change the period of the pendulum from 2 seconds into 1 second? Thanks for watching. See you in the next video.